Welcome to everyone, I'm Paulo Sorricchio, I'm a student at DigiPen Technology, and with this video I'm going to be showing you one of the two projects I did for the CS562 course. The CS562 course is Advanced Rendering Techniques, and basically we had to choose two papers and from a list of papers regarding pretty much every graphic techniques, every latest graphic techniques, and we had to choose two papers and implement them. Basically I chose to implement volumetric lighting as one of the two papers. The other paper was SSO, and this demo in particular is a volumetric lighting demo. What is volumetric lighting? Basically volumetric lighting, I have a scene like the one you are seeing right now in the video, and I have a light in the scene that can be any kind of light. In particular, this is a spotlight. And what happens is that I'm simulating the effect that you have when light passes through dust or in general in the air, and it creates ray shafts due to the dust that is in the air. So it's probably just showing the demo than trying to explain. So this is the final effect. As you can see, they're also called God's rays because it seems like a divine effect. And as you can see, okay, as I go through the scene with the camera, you see the rays that are going through this grid. I chose this grid just to show the effect of how the lights pass through the object, and it creates like this volumetric it's a volume of shadow, if you want to say, it's a volume of shadow if you want to call it like that. And I can show you really quickly all the steps. Basically I'm generating the shadow map from the light point of view, so the light is completely dynamic, so I'm generating the shadow map from the light point of view, and then when I draw the scene I need to generate the color, the diffuse color. So you just see this just the diffuse color of the scene with a simple for lighting algorithm, and then I have to generate a depth map from the camera point of view. So this is my camera, my 3D camera. What happens is I basically ray trace the scene, and what I do is for each ray I sample toward the direction of the light, and I see in the light shadow map if the pixel is in shadow or not. If it's in shadow, well, if the pixel is not in shadow, I accumulate a certain light factor, and then I add the light factor to the scene. So let's see, I can show you just the ray, the volumetric lighting. As you can see, this is just the volumetric lighting buffer. I'm actually, since I'm ray tracing, I'm doing this operation to be really efficient on a 320 by 240 texture. So basically it's like this scene that you just saw, just the rays. This scene is being sampled. Since I have to do many operations for each pixel, the fewer pixels I have, the faster it's gonna be. So I sample just in this corner, 320 by 240, and then I upsample and I filter the scene. So this is just the volumetric light without any diffuse color. This is just the volumetric lighting buffer, I would call. So I can show you even since I'm sampling, I have sampling artifacts, and I have to introduce noise to avoid the sampling artifacts. So I can show you how the sampling artifact. As you can see the sampling planes. So you can see here that the various sampling planes, and that's because I'm doing a constant sampling. So that means that unfortunately I'm gonna have this pattern repeating in the scene. So what I do, I introduce some noise. Noise means that I'm introducing some randomness to avoid this sampling. It's a common technique. When you have sampling artifacts, introducing noise is a common technique. So I introduce noise. Now I'm introducing noise. But if I introduce noise, of course, there's, well, by definition, there's noise in the scene. So what I do after introducing noise is blurring the entire buffer. And with buffer, I'm always talking about the ray buffer, the volumetric lighting buffer. And this is after the blur optimization. As you can see, it is really a nice effect. It works even if the light is really far from the scene. So now the light is at 8 and 8, but if I put it, I don't know, like at 30 and 30, you can still see that you can still see the rays, and you can still see the light is still up there. And even though you can see in the shadow map, it's really there is really a few pixels that are representing my grid. I still have a nice effect on the screen. So I would say that this is definitely a good result. I can not draw the room to see the entire God's ray up to the end, and I think it's really cool just passing through the object to see the rays passing through the grid. And yeah, that's pretty much it. This is the CS562 project, and I hope you guys enjoyed this video, and I'll see you guys next video.